the monitor view, part 2. Let's take a deeper dive into SPUs, signal processing units, which are the vehicle that biosignal.network uses to do feature extraction on biosignals. Okay, let's sign in as demo 1. We'll click here to bring up the monitor view. And we'll click on overlay to hide the video. We're going to focus on this section down here, which is the SPU. So we're going to hide this. We can do that by clicking on controls. They have disappeared. And now we have spectrum and scope highlighted. This is spectrum, frequency domain. This is scope, time domain. Synchrony is there, but we'll leave that for a separate video. Let's hide some more. We'll hide the scope and we'll hide the spectrum. And what we're left with is referential SPUs and differential SPUs. 1, 2, 3, 4 referential SPUs. 1, 2, 3, 4, 5, 6 differential SPUs. Biosignal.network is configured for a maximum of 4 channels, and if there are 4 channels in the protocol, then there is 1 referential SPU to be associated with each channel. Differential SPUs, they reflect, again, if it's configured for 4 channels, then differential SPUs are where you subtract the biosignal from one electrode from that of another. So in a 4-channel configuration, you have channel 1 versus channel 2. 1, 3, 1, 4. Then you have 2, 3, 2, 4, and 3, 4. A total of 6 possible combinations. So again, if configured for 4-channel protocol, you can have 1 SPU associated with each of those configurations. Total of 10, 4 here and 6 here, SPUs are available. Rarely, if ever, are they all used. And in fact, in this configuration here at the moment, we can see that, well, firstly, we can see that it's a 2-channel protocol. So we have 1A and 1B, 2 SPUs assigned to channel 1, 2A and 2B, 2 SPUs assigned to channel 2. The green means that they are active. And in fact, we can hide them further, but they're still green. They're active. These that have no highlights at all are not active. By active, we mean that they are configured to control feedback, whether it's the volume or the size of the video. The SPU, if they're marked like this, they have some control function. These others are not used in this particular protocol. So let's go a bit deeper there. We'll click on this and we'll click on that, and then we'll call up the spectrum, frequency domain, and the scope, time domain. And to see that they're active, we can see that SPU 1A has some functions assigned to it: chime, size, and GIF, animated GIF, or a video cue. Controlled by this SPU. This one here, which is SPU 2A, also has a function assigned, the volume. It controls the volume of the video. Now, if we click on a third SPU, which is shown as inactive, we'll see that there are no function assigned to it, and that's why it's inactive. It doesn't control anything. It doesn't do anything, so we don't need to see it. All right, so what do we got? To do the feature extraction, the key point is this black line running through here. Positive deviations represent frequencies that will contribute to a reward. Negative deviations represent frequencies that will contribute to an inhibit. We can see that there's a different, this here is in fact called the protocol profile for channel 1 and the protocol profile for channel 2. All frequencies that fall here will contribute to an inhibit. The rewards and the inhibits are up in this section here. First, let's look at this row of numbers here. Generally on the left, where it's green, are rewards, and on the right, where it's red, are inhibits. Now, each SPU, in fact, generates 6 control signals, 3 logic signals, yes or no, and 3 analog signals, constantly varying. One for reward, one each for reward, one each for inhibit, and then one in the middle, which might be both a continuously sliding scale between reward and inhibit. So let's look at that. This number here in the middle, in blue, is in fact, yes, it's the analog. This row here of numbers is the 3 analog control signals. This up here that's flash on and off are the 3 digital control signals. Reward in green, inhibit in red. When they flash, it's saying that the digital reward or the digital inhibit is active. There, rewards just generated. Inhibit just generated. Analog control signals. The one that sits in the middle, which is proportionally between reward and inhibit, it's nominally at a value of 50. It can go to 0 for an inhibit. It can go to 100 for a reward. These are rewards only, and they again vary from 0 to 100. The higher the number, the more stronger is the reward. And in here, the higher the number, the stronger is the inhibit. What we can say is that when this flashes red, there is a animated GIF, a visual cue generated, and that will be bad. It will be saying, no, don't, there you go. No, don't do that. Let's have a look at that by going to the overlay. We'll wait for this to go red, and we should see, there we go, there, and red. That's the animated GIF that's just been generated by the inhibit. Okay, enough. Get rid of the overlay. Next, we have these numbers here. They're the smoothing filters. In the middle, we have the analog smoothing. So how fast that can change, controlled by this number here. In fact, the reward, how fast that analog reward changes is controlled by this number. How fast this analog inhibit changes is controlled by this number. And the one in the middle is controlled by both of them. Generally, it's considered to be in seconds, so it can go up to 32. And then 32 seconds is a long time constant. And then that's a fast time constant, quarter of a second, and you can see it changing more rapidly. These here control the logic rewards. First one is how frequently do you want this reward, logic reward, to be generated? It's trying to adjust itself so that it gets generated every 8 seconds. And once it is generated, how long does it stay for? It stays for 2 seconds. That's the hangover. A logic reward generated every 8 seconds, which is sustained for 2 seconds. A logic inhibit generated every 8 seconds, and it's sustained for 2 seconds. They're the smoothing filters. They will generally be adjusted to match the type of media presentation. For a video, you might want it quite slowly moving, but for a game, you might want it fast moving. These are adjusted according to the feedback presentation, and then they are saved as part of the media design. So you have matched these smoothing filters to the particular feedback presentation you're using in that media design. Next video, we'll go into more details into how we adjust the protocol profile using the side panel.